Okay, so here's lesson one. If you missed lesson one, you're going to need to come back to this. That way you understand what's going on. So basically, our anchoring phenomenon, which just means like the very initial thing that we observed that we're going to study based off of. And this is going to be all about like thermal energy, which is heat. So right here it says, I've been buying ice drinks for years using a regular cup. But my drink always warms up and waters down. The designers of the fancy cup claim that the cup can keep a drink colder longer. So it's why does the drink in the regular cup warm up? So the regular cup would be like, and you can tell a little bit of a difference here. This is regular. This is what they're going to call fancy. Okay. So why does it warm up? Do you have any ideas on how it warms up? Or how could the fancy cup keep it from warming up? So people have claimed like this cup that looks about the same, it works better. It keeps your drink from warming up. So here your ice is going to water down and here it does not. Do you have any predictions or ideas why this cup might do better? Or why this cup is not going to keep your drink cold? That's just like regular like restaurant cups. They would give you this little flimsy like plastic cup. All right. So we did a test. Actually, did I already? Okay. So what we did was to prove this, I went and I got this fancy cup or regular cup right here. This is just from like Cafe Latte. Super flimsy cup. This one is regular. I mean the fancy one. It's a harder plastic. The lid's a little bit different. You can tell that's like a reusable lid. Also, it's dishwasher safe. I noticed that on the bottom of this one. This one's just a throwaway cup. It has like a recycle sign on it. So I started with a cup of the same temperature water in both. It was like room temperature. And then I had a cup of ice in both. I had a cup of ice in this one, a cup of ice. So they started with the exact same things. And then I watched this temperature. And then after 30 minutes, I noticed this is what it was right here. And we put this in a data table. I'll show you the data table in a minute. But after 30 minutes, this was 38.3 and this was 39.9. So obviously this one is warmer, but it's really not that big of a difference. Okay. So yes, Fancy Cup looks like it did better, but I don't really know how much better. Is it worth buying this Fancy Cup? Okay. What are the parts of each cup system? So now remember, a system is just going to be anything that has multiple parts that work together. Okay, so write down the parts you think that there are. Just list them. Just put, like, for example, the straw. What parts do you see? When you're thinking about systems thinking for science, which I know this is a really simple system, but everything that has different parts that work together is a system. You would think if I were missing, for example, the straw, would this work? No. So that would be a part that you need to list. So list what you think are all important parts. Okay. So I would have said the lid, the straw, the cup, maybe the material it's even made out of, or this one, it actually looks like it has layers. So those are all different parts. We're not going to answer this right here. You don't have to write anything on there, but obviously, like the lid's going to keep it from spilling. The cup is keeping the liquid in a form, holding it for you, and the straw is what's going to help you get the drink out. Obviously, okay. How do they work together to keep the drink cold? So, what important parts do you think would keep that drink cold? Okay, this is where it was going to ask you to draw a model. Let's go back to, it's not letting me click back. Hold on. Right here. What parts of this helps it stay cold the most? Like, is it the straw? Which parts? Is it the lid? Is it the actual material of the cup? What do you think helps the cup stay cold the best? And so obviously right now for science, we're trying to understand how to maintain temperature. That's kind of what we're studying right now is movement of temperature, the energy that's in heat, and that kind of thing. So this is where we're kind of starting off. So answer really quick. Which part or parts do you think keeps the cup cold the best? Okay, this is where we were supposed to draw it. And so what I drew is I just put a regular cup, just a little system, and then fancy, I just made sure I drew 2 layers. You don't have to do anything there. We shared our models. Okay, so now this was this is what someone else did this once they did this test right here. This is their data. So regular cup, to read a table, you need to go straight across. After 1 minute, it was 41 degrees. After 10 minutes, it was 43. 20 minutes, 46. 30 minutes, 48. And then this one right here, fancy cup, it started also at 41.9 and it went to 46. So as you can see, that temperature change is 4.1. So this one increased 6.3 degrees. This one increased 4.1. Okay. So this is the same question I asked you a minute ago. Okay. Give me just a second. Okay, this question right here is what I want you to answer for me. Let's think about things that would be similar that keep things cold or hot. So try to list some things that you can think of in your daily life that would keep things cold or hot that's not using electricity. So for example, a fridge. We're not going to put fridge because it has electricity. So what else can you think of? I want you to list some things. Okay, I can think of, this is what was mentioned in class, a cooler, a thermos, those like screw top lids that people would bring like ramen noodles or soup in their lunchbox. A lunchbox is another one. Lots of different ideas, but those were just a couple. So I can't wait to see what you put as well. How do these things work? Well, a lot of people noticed most of those things have layers, and a lot of those things also have lids. So let's keep on going. Okay. I need you to write one question. And let's see. We're going to be looking at what's the difference in the regular and the fancy cup. Do you have any questions on how things like this works? Like, for example, somebody asked about like a cooler. Could it also keep things hot? So think of how or why questions that would lead us in the future of like investigating how temperature works. How do we maintain a temperature? How do we keep it the same?